This question comes from Matt. He asks what would happen if the moon were replaced by a black hole with the same mass, and what would a lunar, or even a polar, eclipse look like? I won't spoil the full answer yet, but we'll eventually be talking about temperature changes measured in millidegrees Fahrenheit. That should already hint at how little a black hole moon would actually affect Earth. A black hole with the same mass as the moon would have an event horizon about the size of a grain of sand. More specifically, it would be comparable to a fine to medium fine sand grain, the kind that could pass through a very fine sieve. Of course, a real black hole wouldn't politely pass through a sieve. It would destroy the sieve instantly. But that's beside the point. Literally, once you're inside a black hole, its singularity isn't really a location in space anymore for you. It becomes a moment in time. The key thing is this: the moon's mass and position wouldn't change. Because of that, Earth's orbit and tides wouldn't change either. When you're outside a spherical object, gravity depends only on the total mass, not on whether that mass is spread out or crushed into a single point. In fact, if the sun itself were replaced by a black hole with the same mass, Earth would keep orbiting exactly as it does now, although life on Earth probably wouldn't. Enjoy the consequences. With the moon compressed into a black hole, there would be no moonlight. That alone would disrupt the life cycles of many nocturnal animals. Still, compared to the damage humans have already caused ecosystems, this change would be relatively small. This black hole moon would be extremely low-key. If it were much smaller, it would slowly evaporate through Hawking radiation. But at the moon's mass, it would actually absorb more energy from cosmic background radiation than it emits. As long as it didn't consume anything, it would stay completely dark. If the black hole did swallow nearby objects, it would release enormous bursts of radiation. Accretion disks around black holes are among the most efficient energy-producing systems in the universe. Fortunately, there isn't much nearby material for a moon-mass black hole to feed on, so it wouldn't shine very brightly most of the time. It would simply disturb the orbits of nearby dust, one grain subtly tugging on another. There would, however, be one noticeable effect. Earth wouldn't just get darker, it would also get slightly colder. Moonlight does warm the planet. Measurements show that Earth's global temperature follows a roughly 28-day cycle, peaking during the full moon. The difference is tiny, but it's real. That said, most of this temperature change doesn't come from moonlight itself. The biggest contributor is that Earth is slightly closer to the sun during a full moon than during a new moon, something that would still happen even with a black hole moon. Calculating how much energy the moon actually contributes is surprisingly complicated. The moon doesn't reflect sunlight evenly across its phases, and a half-lit moon is far less than half as bright as a full one. Once you factor that in, things get even messier, because physics likes to be difficult. On top of visible light, the moon also absorbs heat from the sun and radiates it back as infrared energy. That infrared radiation affects Earth's temperature about 10 times more than visible moonlight does, though still about 10 times less than Earth's changing distance from the sun. Specifically, infrared moonlight warms Earth by about 1.2 millidegrees Fahrenheit. In other words, without it, the planet would cool by that amount. But considering how quickly we ray adding carbon dioxide to the atmosphere and altering Earth's energy balance, we would offset that cooling in just a couple of weeks. So overall, replacing the moon with a black hole of the same mass wouldn't be a major problem. Unless, of course, it happened on a very specific day in 1969, in which case a famous quote might sound a little different. One last thing. You might be wondering what would happen if the moon were replaced not by a black hole of the same mass, but one of the same size. In that case, the black hole would have about 600 times the mass of the sun. At that point, both Earth and the sun would fall straight into it, a total, final, lunar eclipse.